on metrics aspect of Eclipse MicroProfile. What I'm going to talk is one slide about me, a little bit about MicroProfile for all those who don't know it yet. I will talk about health checks. We'll talk about monitoring metrics and MicroProfile metrics sub-project and spec, and a little bit about the open tracing, where originally when I submitted that, I thought it will be in 1.2, but it didn't make it. Yeah, so I work at Red Hat, live here close by in Stuttgart. I am or was the spec lead for the MicroProfile metrics specification, and on social media, Twitter and GitHub and whatever, I'm Pilhun. MicroProfile, who does not know it yet? Okay, so it's an open effort to basically build some enterprise Java services for the cloud. Historically, there have been the EE7, Java EE7 from Oracle. This was done, I don't know, 3 years ago. And then the world has changed since, so systems like Kubernetes and Docker showed up and got very popular, and people are now not deploying virtual machines on Amazon, but they are really packaging smaller services, putting it in a Docker container and scheduling that. And we had to basically react on that and make the Java enterprise environment more suitable to the cloud. And some of these things we have to do is, and I talk about that in a minute again, for these automatic schedulers like Kubernetes, they check the health of your container, of your running application, and if it's not healthy, they restart it. So we have to somehow support that notion and other cloud patterns. And there were some talks already yesterday, like Emily talking about fault tolerance, which is another of these services, and configuration and whatnot. And this is about the metrics aspect now. So the MicroProfile effort, there are a lot of involved parties. I copied these white icons from the MicroProfile.io website. So there are vendors like Fujitsu or Red Hat, IBM involved, but also individuals. These two. No, I'm joking a bit, but we should probably put that on the website as well, because we do have these individuals indeed, like John and Werner. Yeah, Marcus, and also other organizations like the Brazil Java User Group and London Java User Group, who have been active writing or providing input on the spec writing, providing infrastructure and everything. So this is really an umbrella thing and not dictated by one company, but really something that everyone can come and work on and help out. And if you have a new idea for a new spec, you present that. And if the general community says, yeah, that's a good idea, then this continues and everyone can be the spec lead for this new effort, and the others will come and help out. So as I said, specs are by the community. The idea is to have a quarterly time-boxed releases. So we release every quarter, and what's in is in. Some of the specifications may see an update for a new release. Others will stay on the same version for 2 MicroProfile releases. That's all fine. And just for the history side, so MicroProfile 1.0 was presented a little over a year ago with CDI, chunk size, chunks P. So the JSON processing as the key thing. And then MicroProfile 1.1 was released earlier this summer with the config feature. And then just directly before Java 1, we released 1.2 with 5 new specifications, an update to config. Yes?
Just to clarify your presentation, in case someone's asking, it's not JAXP, it's JSONP?
JSONP. Okay, no, I'm not online editing now. Yeah. I have no idea what may happen. Okay, JSONP, sorry. So we added the health checks, fault tolerance, and the Java Web Token. And so I'm now talking about the health checks. There should be an icon in the left corner. I'm not sure why it's not showing, but anyway. So the question is my system healthy? And I mean, you can, of course, look, is the Java process there? And if it's not, then it's obviously not healthy. But just because it's there, it doesn't mean that your system is doing anything sensible. And in the past, I mean, probably everyone has seen that your process is there, and it's using huge amounts of CPU. And if you look at the log file, it just says GC overhead exceeded, GC overhead exceeded, and it's running in GC loops and doing no business functionality. And we want to catch that, and not only like in the old way where an operator is then looking at that stuff, doing some PS and top and log file tailing, and then, okay, saying, yeah, that's not healthy, let's kill that and restart it, but in a machine consumable way, so that systems like Kubernetes that do these pings regularly can check in, and if the return code says okay, then it's good, and otherwise Kubernetes will just kill that container and start a new instance of it. Perhaps not exactly in that order, but you get the idea. And the default check is via an HTTP call here, and if the return code is between 200 and 399, it's considered healthy, and if it's something else, it's considered unhealthy. Hello? Ah, now it's there. Nice. And so you will probably see the same animation on this slide as well. For the health checks, what you have to do, and I show the code in a minute and in a demo again, you have to provide a class that implements the health check, annotated with @health, and this has then one method call that provides a health check response inside, and there's then a builder inside where you provide a name, can add some properties that are then copied to the output, and then here on, you basically, before you build the result, you can either say down or up, and that's it. And I think for health check 1.1 we want to change this a little bit so that you can have an arbitrary method with a signature that returns the health check response, that you mark that with @health, and that then the name of the method is basically directly the name of the health check, which I have to manually provide here at the moment. It's sort of a very often requested feature. I'm not sure if someone is already working on it, but I think that's something we were going to do going forward to make it more easy, and then you can really have one or many classes that just implement a lot of these checks. So it's not like you only have one check, but you can have a lot of them, and the system is then combining them together, so you can have one check per backend that you want to talk to. Could even be matched with the fault tolerance system, so that on one of these fault tolerance things you also put an @health on it, and automatically, if the number of retries is exceeded, health is returning a down or similar. So more animations, and then when you have this set up, you go to your server URL /health endpoint, and this will then return a data. So here a 200 OK, so it's good, and will respond with an outcome of up, and here, so that's the overall outcome. And then internally it has a list of all the checks that we have. So this was the alive one from before. State is up, and the additional data that we provided. Okay, demo time. This time a Red Hat guy showcasing Liberty, open Liberty. Yeah, so I mean, I'm demoing. I could also showcase that on Wildfly Swarm, but the implementation that I have on disk still returns a 204 for the empty check and not the 200 from the spec. So this is why I'm demoing. I mean, it's not yet in master, so we don't say it's compliant yet, right? Okay. So I have this here, an Open Liberty server already set up with a profile named MP1, that the name is arbitrary. And I start that. It has been launched, or it's still launching. And now I can go to my and this is now returning a 200 as I've promised, and an array, so an outcome of up, and an array of empty checks. This is because this is the empty server without any of these health checks installed. This is so even if you don't do anything, the system responds with at least something, right? So when you have these health checks enabled in your system. And now when I go to my, this is not what I wanted. So this is my my code. I have a CDI bean with the add health here, implements health check. We name it alive and not hello world, but EclipseCon. And I can go to my IDE, do the magic to create the output, and now in the oops. So there is a demo.war over here. And now I need to remember the location where I've put the copy target demo war to nope. Drop-ins, right. So I copied that over. Yeah, so Liberty has started this one. So I can now do the same curl call again. And here you see, okay, why is it hello world? That's probably because I didn't find a chicken to sacrifice to the demo gods. But you see we have installed the application in the server, and now it's returning my health check here. And so I'll continue. That's sort of funny. So that's the health check API, and now let's continue with the metric specification. The metric specification deals with telemetry data. So basically all the data that's coming from the server, like memory usage, but also from your application, CPU usage, application, so number of billing or of card checkouts, whatever you want to expose to external systems. And the telemetry data, the basics, is usually used for capacity planning. So how much CPU am I using? Do I need to order a new server from my vendor? So that I can predict that. It's also used for billing purposes, like how many CPU minutes are spent, or how many transactions have been run, and so on. And the other one, which is very popular, obviously, is graphing with dashboards like Grafana or you name it. And within the metrics spec, we have currently identified 3 scopes of data. And the first one are the base metrics. This is a set of metrics that each vendor has to supply, and has to supply under the same name, so that let's say the thread count is always the thread count, no matter if this is taken from Wildfly Swarm or Open Liberty or Tommy or whatever. And then we have another scope, which is vendor specific data. So for example, Open Liberty is running an OSGI container. They may have different statistics coming from the OSGI side that Wildfly Swarm, that is running our module system, where you have a metric like number of modules loaded and unloaded or similar, which does not exist in yet another server. So this is very server specific, vendor specific, and it's also not portable, and it's also not required that the server is giving that data. And then the third scope for now is application data. That's something that you expose within your Java application, and I'll show you how in a minute. And this is then exposed to these monitoring clients or agents in the same way as the others. And within the data, you have these scopes, so you can also query for individual scopes. You do not have to always consume all the data, but you can if you want. And for the monitoring agents, we do have a REST API. This if you do not specify a media type, it will reply with the Prometheus text format. Prometheus is a system that has, or a monitoring system, time series database that has grown tremendously in popularity over the last few months. And this text format has become somewhat of a lingua franca between all these systems. There are Prometheus exporters left and right for all the systems. So we said it's a good idea to support that from the start on. The other thing what we do have is a homegrown JSON format where you can get at the data itself with the normal GET request. So you do a get/metrics and you get the data. And if you do an options request, you get additional metadata, right? In a Prometheus format, they do have that in some hash help and hash type lines. And here we said, okay, it's important to have metadata in both cases so that systems machines can actually make sense, because when you look at older systems like JMX, there is a bean or attribute, it's called foo, and it returns 42. 42 what? 42 seconds, 42 milliseconds, 42 shoes, right? You do not know that, and for you as a developer, it's obvious, that's milliseconds, right? But now imagine the ops people that are woken up on Sunday morning at 3 a.m. Foo is above 42. What does that mean, right? So that's where it gets very important, that you have the metadata, that you have the way of describing, okay, there is a description, this foo is the number of yada yada yada, the unit is in milliseconds or is in hours, some transactions or backup running for too long, whatever, so that they can make sense of that. Also, it's important for graphing with Grafana or others, because now when they know it's seconds or milliseconds or meters or whatever, or bytes, they can apply the right scaling. I mean, for seconds, it's with 60 seconds, 60 minutes, 24 hours, yeah, so you cannot just divide by 1,000 to get at some human readable format with this long number. While with the bytes, you have the 1,000, the kilobits or the KB and the KB, right? So sometimes you divide by 1,000, sometimes by 1,024, and when you have that, the machine can then do the right scaling for you and present it in a human readable manner. That's, I think, pretty important. So quick demo here again. I'm not sure if this one already is. So I do have still the, no, it's actually with all three servers, the Open Liberty running, and I have a, where are we here? So I'm doing a curl call for the metrics under the base scope, metrics/base. If I would only give metrics, it would expose everything, and now it's only the base scope to show that this is something that really each vendor implements, right? And now you get this list here. You have here the type, it's a gauge. You have the help text, so here displays the amount of used heap in bytes, and then you have the real amount, right? So the real value. And this is how it looks with Open Liberty. Now I have over here also started a Wildfly Swarm instance, also not yet loaded with an application, or in this case. And let me, in the background, also start this Cumulus instance. When I go back to here, I can also do the so that's what Wildfly Swarm shows. It does not have the help text yet, so only the type part, but it's the same thing. And then if you go for port 10,080, this is what Cumulus reports. And I have now created a little script, which is basically just running the curl commands, removing the lines from the help text, so that it's only the metrics lines and the values to show you that these servers all return the same set. Yes, sure. Right, so this is the text plain format, because this will not request application JSON by default. Actually, I can show that in the console. This format, right? And so this is, you can read it, and this is also this Prometheus text format.
So do you have a plugin to the Prometheus? Can you show like a graphic?
I come to that. Don't spoil it. So before I run that script, that's actually a good idea. So this is how it looks in JSON format. And if I do not do the standard of a GET request, but X options, yes. Okay. Yeah, now you see for all of these individual items, you see it's the unit, you see the type, it's a counter, and then also a description. So this is really a help for the operation people when they get that, because then they also have a possibility to look at the metadata and a description, and then much better decide if this is really critical or if they can go back to bed.
Is there a schema for the values for unit and type so that the machines can understand it? Because if you don't, there's not a well-defined list for units.
Yeah, so yeah, we had some discussions of that. We do have a list of units right now. It is, when we started, it was an enum where we said, okay, it's only a very limited list, but there you cannot make mistakes. But unfortunately, enums cannot be extended. So if someone really has the need to expose a unit of foo, he could not do that. So we turned that into strings, and we will, I think in the next version, add something that the server has to complain if something shows up that is not in the known list.
Right, but in order for a machine to pull the options thing and then process it, it has to be able to understand it.
Yeah, yeah. I mean, what we have done in the Prometheus format, the text format, is to use units, always the base unit of the family, which is what Prometheus then understands, and also scale it accordingly. So for when it's here a milliseconds and we have 300 or 3000 milliseconds, right? Then in Prometheus format it would be 3 seconds. And then with the seconds in the name, and this is,
you use like SI, you have a standard for
yeah. So this is highly controversial. There are probably as many standards out there as units exist.
It's a great thing to like shit.
Okay.
I'm sure Jason's probably has a dozen.
Yeah.
One question I have is this hypermedia enabled?
In what sense?
Well, the the output doesn't seem to link back to all of the other possible, you know, so that an HTTP client can navigate through without having to
Yeah.
know more information.
Yeah, no, it's not yet done really in that sense. We were thinking about it, but we also had somewhat time constraint, and we need to think about it more. And also what we want to do in the next iteration is also add another scope for other microprofile specifications. So Emily showed this fault tolerance yesterday, and actually if you say, okay, do 5 retries and then give up, then you also want to know about it. Or even if it's more than the direct call, you probably want to expose the number of retries, or if timeouts hit, or how long things take, so that, because I mean, if you always do 4 retries before something succeeds, then you have a problem even if your software overall runs well. Well, for whatever the definition of well, because I mean, if it does not have to retry, it's obviously better, right? And this is something where we want to add another scope with some namespaces inside it, and then the other specs can expose their stuff in there. So this is also something we need to figure out and do the namespacing and the hype. Yeah.
Would really help with that, because then you'd be able to navigate.
Yes. No, I agree.
Proprietary
Yes.
sections.
But then it was humans to click on stuff. But this is important for
Yeah, but even
dashboards to scale everything.
Yeah, but hypermedia is not for humans. It's for clients that are smart HTTP clients.
okay, let's quickly go back to here because I'm running out of time a bit. So this is a diff between what Wildfly Swarm and what OpenLiberty is exposing. OpenLiberty has one more metric here in the base set. This is because we do have 1 or 2 which we said these are optional base things. So if the server can provide it, they can expose it, but they do not have to. And it's okay if you don't do that. And the other one is a diff with between Swarm and Cumulus, and they don't have these 3 yet, or Cumulus does not yet have these 3, but they're working on it. They don't claim compliance yet, so because the TCK would test for that. But I got a pre-version to showcase here, and because for me the message, the most important part here is no matter which server you have, you can get the same data, and this is actually something that Emily already was coming to or asking for. So I have a Prometheus instance. I just started that empty, and when I go to my browser, this is probably old, so I go to the status page with the targets. So all the targets have been found and are being scraped. And now I can go here for metrics, and when I start with base, you see the list of the base metrics, and now let's pick one. And memory used heap bytes, execute. So either here I get just the raw values, and you see Prometheus is adding the instance, so where it's scraping from, and the job name from the configuration. We have facilities to add more tags, be it on the server level, be it on individual metric levels, and so on. And if I go over here to the graph section, you see that's the current memory usage of the 3 servers. Don't be alarmed that one is higher than the other, because they just did not trigger a garbage collection yet. So if I would forcibly trigger a full collection, they would all be somewhere down here. So this is, but on the other hand, it makes it much more interesting if the values are different than if they are all a straight line, all 3. So, need to speed up a little bit. So for the Java, I mean, you want to also expose your values, and for the Java side, we have an API, and if you know Drop Wizard metrics, this API will look extremely familiar because we have taken some of their stuff, modified it, turned some of the concrete classes into interfaces, and also enhanced the handling of the annotations via CDI. And so when you write your code, you can basically do something like here. I inject the counter, and as this has no additional data, I will have a new counter with the name of a counter, and in the output it will show under a counter. Here for this histogram, we have also the add inject, but we want to provide additional metadata. So we put an add metric on it. It's absolute, so the name is not only histogram, so it's only histogram, while here the class name is prepended to make it unique. And here we said, okay, no, that's already enough for us. And I have added a tag that would then show up in the output of the listings, right? And then here you can, after you have the counter, you can just increase it or update the histogram. And yeah, so basically you just put this annotation on it and the system does all the magic for you. And similar to that, here is a chucks rs method, doGet, that is exposing a response. So I can increase my counter that I've defined above and also read from it a counter.getCount, right? But that's not the real interesting part here. I can also put these annotations on it, like add timed on this doGet. So automatically each time this is running, the execution time is taken and reported into a metric with the name of hello time. It's absolute, so it stays at hello time. And I have a description from the metadata, timing of the hello call. I do not have a unit set because this is always a time. And I think we said nanoseconds is here, nanosecond precision is the default. And I want to keep it at that, so I do not need to provide the unit. And again, I have added tags for this one. So in this case, this doGet is from an application which is the shop, and then some timeline. This get added to the overall list of tags. And then I'm also counting how often is this called, just for demo purposes. And again, here, tags, description. And when you run that, you see it in the output of the server. And I'm skipping this part. I would have shown the application metrics and compile, but due to time reasons. And now I want to quickly, in the last 2 minutes, talk about the open tracing, which did not make it into 1.2. In the classical architecture of a monolith, it's pretty easy to figure out where your time is spent if something is slow. You attach a profiler to it, and then you trigger a call into the server, and the profiler gives you the call tree. But now you have microservices, 5, 6, 7 services talking to each other, perhaps even retrying. And when you poke one service with a profiler, you probably see something, but you don't have the full picture where things are coming from. And this is where you need something like a distributed tracing. And so consider we have this dog buying some food, dog food from his preferred supplier, and this is a microservice architecture, and this gateway service is calling for this service, which is probably looking for the credit card, if it's authorized, and here for the shopping cart thingies, right? And what you want to know at the end, or what the customer want to know is how long does it take, or why is it so slow? Well, the customer doesn't want to know why it's so slow. That's more the admin. But if it's too slow, the customer will just run away and buy somewhere else. And what you can do is, with open tracing, you can either at a level of a full service or even smaller, like on a method level, add instrumentation, and whenever that's called, you get the timing output, and then it's all in this open tracing specification. How does this done on the programming model? Do you send it to a server, and on the server you get then a visualization of this blue time, that's the overall time that the dog was seeing or waiting, and it's composed like this much in this yellow service, and the green part is happening in the database. And luckily, the blue service was already running 2 services in parallel, 2 calls in parallel, because the other one, the gray one, was also taking a lot of time by doing some work on its own, calling the red one, calling into this database, and then doing a little bit service at the end, right? And this is where the specification comes in, and where we want to make it easy, also again with annotations and all that support, to support this tracing of the microservices, because otherwise you can't really handle the complexity if something is slow. And unfortunately, it did not make it into 1.2. As I run out of time, it's good that there is no demo. And this is the second to last slide. So this is a list of resources. The demo, my demo code is in the first link. Then microprofile.io is obviously the place to go. It's the Eclipse technology project. Then I have WorldFly Swarm.io. This does not yet have the code base, but it should be merged within the next 2 days into master. So with a little luck, it's in the 2017.11 release or 11.0, otherwise in a subsequent one, but should be appear there any day soon. And then I wrote 2 articles on the Red Hat developer blog. So this is a general one about concepts of metrics and health check. So it's an overview, real vendor independent. And the second one is now showing what we have done with Prometheus monitoring and how you set up some of the servers. So check it out. And you know the drill.